Hello everyone and welcome. Today we're jumping into a chapter that honestly is one of my favorites. It's chapter 9, Some Applications of Trigonometry. Now you probably know it better as heights and distances, right? And I promise you, by the time we're done here, you're going to see just how logical and more importantly, how high scoring this chapter really is.
So, have you ever actually thought about that? I mean, how do we know the height of a huge skyscraper or a really tall tree? It's not like someone climbs up there with a giant measuring tape, is it? So how's it done? Well, there's a secret mathematical tool, and it's called trigonometry. And that's exactly what we're going to learn how to use today. All right, let's get right into it. The great thing about this chapter is that you only need to understand just three key ideas. If you can get these three things down, I'm telling you, every single problem becomes so much easier. So let's break them down one by one.
First up, the line of sight. Okay, the definition sounds a bit technical, but don't worry about that. It's actually super simple. It's just the straight, imaginary line from your eye to whatever you're looking at. That's it. So, if you're looking at a bird in the sky, that line from your eye to the bird, that's your line of sight. Easy, right?
Okay, number 2 is the angle of elevation. Just think about the word elevate. It means to go up. So this is the angle you make when you have to look up at something. Imagine you're on the ground and you see an airplane. You have to lift your head, right? The angle between the flat horizontal line and your line of sight to the plane, that's your angle of elevation. And take a look at this picture. It shows it perfectly. You've got the observer, and that straight flat line coming from her eye, that's the horizontal. Now, because she's looking at something above her, she has to tilt her head up. And that little angle that's formed right there, that is the angle of elevation. It's all about looking up. All right, so if looking up is elevation, what do you think looking down is? Well, it's the angle of depression. Think about it. The word depress means to go down. So let's say you're standing on your balcony and you look down at a ball on the ground. The angle your line of sight makes with that flat horizontal line is the angle of depression. And this image here shows it just as clearly. See? The person's up high, looking down. The horizontal is that straight line from their eyes, and the angle made by looking down to the object, that's our angle of depression. So it's really that simple, isn't it? Elevation is up, depression is down. If you can remember that, you are already halfway there. Okay, so we've got the three basic ideas down. What's next? Well, the best way to really understand math is to actually do it. So let's solve a problem together. We're going to take a classic question, and I'll walk you through it step by step. Let's do this. Okay, here's our first example. Let's read it carefully. A tower stands vertically on the ground. From a point on the ground, which is 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is 60 degrees, and our job is to find the height of the tower. Okay, when you get a word problem like this, what is the number one, most important, first thing you should always do? It's not starting the calculation, it's drawing a diagram.
So, let's turn these words into a picture. We have a vertical tower, let's call that line AB. Then there's the ground, which is a horizontal line, we'll call that BC. The problem says the point is 15 meters away, so that means the length of BC is 15. And from that point, the angle of elevation, looking up, is 60 degrees. So the angle at point C is 60. And we need to find the height of the tower, AB. Look at that. Instantly, the whole problem just makes more sense, doesn't it?
All right, step 2. Now we need to choose our tool, sin, cos, or tan. Well, let's look at our angle, 60 degrees. What do we have? We want to find the side AB, which is opposite the angle, and we know the side BC, which is adjacent to the angle. So we have opposite and adjacent. Let's think. So, ka, toa. Which one uses O and A? Ah, it's toa. So tangent is our guy. Okay, so now for the fun part. Step 3, solving it. We know we're using tan, and we know that tan of an angle is opposite divided by adjacent. So for our diagram, that means tan of 60 degrees is equal to, well, the opposite side is AB, and the adjacent side is 15. So tan 60 equals AB over 15. Perfect. We've set up our equation. Now comes a little memory test. You have to know your trig values. What is tan of 60 degrees? Come on, you know this one. It's root 3. So we just swap out tan 60 with root 3. Our equation now looks like this. Root 3 equals AB divided by 15. Look at that. We are so close to the finish line now. And now for the final step. To get AB all by itself, we just need to bring that 15 over to the other side. So we multiply. And we get AB is equal to 15 times root 3. And what are we forgetting? The units. Always remember the units. So it's 15 root 3 times meters. And that's it. We've found the height of the tower. See how that worked? You can totally do this.
Great job working through that with me. Before we wrap up, let's do a super quick recap of the plan we used, and then I have just one, really important exam tip for you. So listen up, this is the good stuff.
Really, it all comes down to this simple 3-step success plan. 1. Draw the diagram. Always. 2. Figure out which sides you're working with and pick the right trig ratio. 3. Just plug in the numbers and solve. That's the blueprint for every single one of these problems.
Okay, and here it is, my number 1 exam tip. The biggest, most common mistake I see is students trying to do it all in their head. Please don't do that. Always draw your diagram first. Seriously, a good diagram is literally half the problem solved right there. It turns a bunch of confusing words into a clear picture, and that picture tells you exactly what to do next. Trust me on this one, always draw it first.
So, how are you feeling? Ready to tackle another one? Remember that 3-step plan. It's your key. Use it, and I'm telling you, you can solve any heights and distances problem that comes your way. Keep practicing, and you'll be an expert in no time. All the best!